All right. So yeah, from the last time we looked at collection initializers, we looked at extension methods, and so on and so forth. Today we are going to look at um, lambdas, delegates, and so on and so forth. But before I do that, I think I think I need to paint a scenario. Let's say, for example, we wanted to filter this list. Okay, wanted to filter it by the people who have a last name that starts with M. For example, maybe I'll add two more people. Let's say, let's call this Maduka. Let's call this Jimmy. Let's call this let's add one more person. Let's call this person Okonkwo. And let's put the first name as Chidi. Okay, Ctrl K, Ctrl D. At least I have a little bit more data. Okay, now let's say I wanted to just filter just the people that have the last name that start with M. How would I do that? Well, this place where I'm having my list, I could come here and say if person dot last name starts with let's say M, starts with M, then that's when I should only print this. Okay, so now if I run it, you will see that only Odin Bebo and Jimmy Maduka returns. Okay, now this is called the imperative way of building applications. Okay, there is because you are telling it exactly what to do. Go to each person, pull it out, check if his name starts with M, then console.writeLine, and so on and so forth. But imagine if I had to repeat this twice. Let's say I just wanted for M and I wanted for O. I wanted for people that ended with O. I would have to come here and replicate this. Okay, so if I run this, maybe I should just put a console.log somewhere that says console writeLine, say people who start with M, and then I would say people who start with O. Okay, all right, this is cool, except if, for example, we don't know whether we are supposed to find people that start with M or O, and part of our requirement is to make sure that we are able to filter by any letter. So you would enter the letter and we would filter this list by that letter. How would we go about it? Well, the mere fact that we duplicated this code twice is already a sign that we should refactor it into a function. To do that, I would have to come here and create a method. Let's call this filter print. Okay, filter print, it takes a letter. Okay, and then let's return void for now. Then we copy one of these, paste it here, so that now it will be, instead of saying starts with O, it will be starts with the letter. Okay, and for people, we have to surpass people as well. So this would be, is it list or array? Okay, it's a list of persons. Let's call it people and do this. Okay, so but now it won't be starts with O anymore, it will be starts with the particular letter. Okay, so by extracting it out into its own method, I can easily just come here and replace this entire code with filter print, right? And I will supply what? O. Okay, I need to first supply people, so supply that, and then I will supply O as a letter. Now if you notice, it's complaining because we are in a static method and we're trying to call a function that is not static, so we have to mark this as static as well. And once I do that, it goes away. So I can also replace this entire code with filter print and this, of course, the same people but this time with M. Okay, so let's run this. As you can see, people who start with M, Jimmy Maduka, Odin Bebo and Jimmy Maduka, people who start with all this. One thing I can also do is to make sure that there is ample space after I've printed everything. So I can say console.writeLine, just write line with a new line character. That way I give 2 spaces instead of 1. And yes, people who start with M, people who start with O, press any key to continue. This is great. This is great. But let's assume that all of a sudden a new requirement comes along and it says, okay, and it says we want you to be able to get people whose first name this time instead of last name starts with O. Okay, that means I would have to come here, replicate all of this, and rename this to like filter last name print, filter first name print. Okay, so let's change this to last name, let's change this to first name. Okay, and then let's be sure. Okay, before I even do first name, let's change this back to last name again. Okay, this is pretty much what we had the last time, with the exception that we need to change filter first name print. So we'll say people whose last name starts with that letter, and this one will be people whose first name starts with whatever letter. So we'll change this from last name to what? First name. Okay, now this is where it gets tricky. Remember the last time we faced a problem like this where we duplicated code? We were able to easily what's the word? We were able to easily extract out the loop into a method so that it was easy for us to just call it instead of having to repeat ourselves multiple times for M and O. But now we're in a bit of a problem, because now we can't really do that, because here we have a last name and here we have first name. So the question now is, how do we, if we're going to collapse these two into one function, we need a way of telling of the function deciding whether it is first name or last name. Okay, so this function can't decide whether it's first name or last name. It will be whatever was passed in that will determine it, and that's where delegates come in. Okay, so delegates come in 2 flavors, right? You have should I just go straight to the original delegate? Yes, I think I should. So the way we would do this is to you know what, let me skip that, because there's no time. So it's to skip to func straight away. So how you declare delegates is using a type. Sorry, how you use delegates is using a type called func. There are 2. There's func, there's action. Okay, let me look for, just give me a moment, let me look for where we can. So let's look for docs.microsoft.com. Here we will look for .NET, and in .NET we'll look for C#, and in C# we will look for, this getting started, core API reference. Just give me a moment. Okay, 12 C# language reference, yes. So here let's look for func. Let me just look for func. This isn't what I'm looking for. All right, so this is delegates in C# or F here. This is okay, this is the syntax of it. But as you can see, you can declare a delegate, you specify the return type, you specify the delegate name, and then you can specify the parameters that the delegate takes. What's a delegate? A delegate is essentially like a function pointer. Okay, it's a way of referring to methods directly. For example, you see this method here that's taking a list of people and a string, and it returns void. You could declare it as a delegate. So we could come here and say delegate, right? It returns void. Let's call this a printer. Okay, and then we can specify that it takes a list of persons, of people, and it takes a string. Let's just call it param, and we close it. Okay, so what this means is that now I can use printer to refer to either print first name or print last name, like so. So I could come here and say just the same way we can store person into person objects, you can store methods into delegates. That's the idea. So if I come here and I say I want printer, let's call this printer1 equal to what? Filter first name print, and as you can see, it works. Okay, I can also come here, say printer2, and I can call this filter last name print. You understand? So just this again, for a quick recap, just the same way you can store values into variables, you can also store functions themselves into delegates. That's exactly what it does. Now all delegates come with a special method called invoke, right? So this invoke, all it's doing is it's calling the method on your behalf, right? So you have to actually pass it the proper parameters. So if I came here and replaced all of this with printer2, and replaced all of this with printer2, right? This is the compiler. So as you can see, it's exactly the same thing. But what we've just done is just to store this method into this variable, just so that we can come back here later and reuse it. But mind you, doing it this way is the equivalent of saying printer2.invoke. Okay, invoke like this is exactly the same thing. So if I came here and said printer2.invoke, it's exactly the same thing. All it's doing is calling. When you call this invoke function, that's when it goes and calls the main function. To prove to you that I'm not lying, let's put a breakpoint here. Okay, let's run the app, and once we hit the breakpoint, as you can see, if I put my mouse on first name, okay, let me step over. If I put my mouse on printer1, as you can see, the name is printer1, and the method is pointing to is what? First name print. Okay, same with printer2 as well. We've stored them in these two delegates or variables or whatever you want to call them, so that we can now come back later and call invoke. When you click invoke, as you can see, it goes straight to the method itself that you are trying to invoke. Okay, this is really useful because now what it allows us to do is to extract out just this line where we are checking whether it is if the first name starts with this or not. Okay, so how do we do that? Well, we can collapse these two, because this is the only part that is actually changing between the two of them. So I can come here, create a different method. Let's just come here, copy this, move it to the top, and this time instead of saying filter first name last name, I'll just call this filter print. Okay, back to the original name we called it. Now the only problem is, how do we know what to use as our if statement? Well, let's come here and declare a delegate, let's still leave this delegate, let's declare a different delegate. Okay, and this time we want something that will return us a boolean. Okay, typically that's called a predicate. Anything that a delegate that returns that takes parameters and returns a boolean is called a predicate. Predicate delegate. Anyway, predicate, because it resolves to true or false. That's actually the meaning of it. So let's come here. It's going to take a person, and it's going to return whether it's what, true or false. Okay, now what this means is I can come here. Let's look at filter print. I can come here, and not only will this list of it take list of people and a string letter, it will also take a predicate. Let's call it our own predicate. As you can see, there's a built-in predicate built into let's see. So yeah, it's still the same predicate. Let's call this predicate. Okay, now here at this point we can now just invoke predicate. Or before I do that, let me create a function, a separate method here. Let's call this starts. Let's make this boolean. Let's say starts with last name. Okay, so and it will take the letter. So let's call this letter. So here all I just doing is it will take person 2 as well. So we'll say person. So we'll say you should just return if person dot last name starts with the letter, which is ultimately this expression right here that you're looking at. I've been able to extract this expression into a method. So what I can now do is let me also create one for starts with first name as well. First name, and this time I will change this to first name. Okay, so these are the only bits that are actually different between these two. Okay, I think at this point I can even get rid of all of this, so I don't need them anymore. I'm about to collapse them into a single method. So what I need to do now is to replace all of this, right, with a call to this. So assuming I had coded this to say starts with, sorry, let me also make them static as well. Static. So had it been, I came here and said starts with first name, and I supply the person and I supply the letter. Okay, that's one way of doing it. The only problem is that now I've hard coded, but let me, before I even get to the predicate thing, this works. The only problem now is I've hard coded. Let's remove all these original delegates. We don't need them anymore to reduce the complexity. Let's just call this filter print, and this time I would supply people. And also supply the letter I want. So in this case, M and O. Okay, I don't need this delegate anymore. We'll get to that. Even this one we'll have to modify it, but let's run it and see if we got what we were expecting. As you can see, people's last names that start with M is only this, and actually what I wanted was hold on, there's even something wrong, because we are supposed to have filter print. If your last name starts with M, oh okay, sorry, it's calling the wrong method. Let's call this starts with last name, so that it does what we expect it to do. And yes, as you can see, it's filtering correctly. The only problem here is how do we change the behavior of this method such that depending on what you call filter print with, it will pick one of these two. Well, a quick way of doing that is to just create what's called a predicate. If you notice, these two methods have exactly the same signature, so we need to create a predicate of that signature. So it takes a person and it takes a string for the letter that you want. So with this now, rather than coming here and explicitly calling start with last name, because don't forget, I can easily come here and say predicate, let's call this predicate equal to starts with last name, just as store it in that variable, if you will. And I could also come here and say predicate 2 and say starts with first name. Nothing fancy, just the same way I'm storing functions. I can store functions into variables as well. So to now make it happen, all I need to do is come here and say predicate, call it predicate, and then replace this starts with last name with what? Predicate, and I'm done. That would mean now that whenever I'm calling these two methods, right, I can specify whether I want start predicate or predicate 2. Okay, predicate 2. So I don't know if this will give me what I want. Why is it unhappy? Oh, okay, need to make predicate public because it's less accessible. All right, so let's run this. Let's see if it works. As you can see, the first one works, the second one works as expected also. Now we could even get rid of these two altogether. Instead of just storing it in a temporary variable that we just use here, we could even pass it directly. So let me just use inline to inline the variables. Okay, so it puts it directly there. So you can now easily specify whether you want first name and last name. So if we run this, you can see it does what we expect. If I come here and change this to starts with last name and do Ctrl F5, we get the same behavior. We get the behavior we expect. All right, now it's a pain, as you can imagine. It's a pain to be writing these temporary methods all over the place just so that we can pass them into a generic filter function. Well, that is where there's a handy syntax for writing things like this in such a way that is easier. One way is to use I think the delegate key. There's a delegate method syntax or something, but people don't really use that anymore. But what we can do is to use a nifty syntax called a lambda expression. But before I get to lambda expression, I think let me do the delegate syntax first. Oh no need. If you notice here where I created this predicate, I had to specify that it takes a person as a first parameter, takes a letter as a second parameter, and returns a boolean. But what would happen if I wanted a third parameter? I will have to create yet another predicate, and before it knows happening, I'll be drowning in predicates. So in order to fix this problem, .NET comes with a nifty set of in the base class library, comes with a nifty set of APIs. So those for action, func, and so on and so forth, they are generic delegates that you can easily reuse instead of you having to write your own predicates all the time. So let's quickly fix that. So there are two types. There is a func and an action. Don't worry, the name it sounds funky, but it's actually very simple. So rather than writing the delegates manually, you can describe these delegates by using a generic func. Okay, so if you notice, if you look here, you will see that this predicate takes a person and returns a letter. It takes a predicate and a letter and returns boolean. If your predicate returns something, you will use func. If your predicate does not return anything or it returns void, you use action. So let's say this predicate was I don't know, let's say it was void here for whatever reason, then you would have to say action of you will now specify the parameter. So we have person and letter. Person is a person object, letter is a string. Say action person comma string. Okay, this is how you declare delegates, or rather this delegate has already been declared as a, in fact, if you look at it, encapsulates a method that has two parameters and does not return a value. So that would be equivalent to this. Another way you could write this, so let's go back to the way it was before because of the squigglies. We change this back to boolean, but rather than using action, you use func. If your delegate returns something, you should use func instead. And whatever you put inside the generic type parameters, those are the things you passed into it. So for example, how I would write this one is to say person comma string comma boolean or bool. Okay, by writing it this way, these two are exactly the same. Yeah, so as I was saying, this is essentially equivalent to writing this predicate as well, but the only difference is that this one has already been declared for you. So I can now replace this delegate, this predicate, with what's the word, this place where I specify the predicate, replace it with this, and as you can see, everything works well. So you could also, again, you could also come here, call this predicate, and then assign it to start with last name as well. It's exactly the same thing. This is saying a predicate that takes two, or rather a delegate that takes two parameters, one a person, one a string, and returns a boolean. So as you can see, that is what we have here. Alright, now the last part, I've been able to eliminate the whole predicate, the whole delegate. Predicate is just a special class, is a type of delegate. So if I do Ctrl F5, just to show that everything still works. And then finally, what we are going to do now is to find a way of getting rid of having to create all these pesky methods all over the place. Well, one way of doing it is you have in C# you have what's called a Lambda expression. What it allows you to do is to create methods and delegates on the fly. Okay, so let's come here, call this starts with last name, and then I can move this entire block here, delete this, and come here and replace it with this. Okay, right. The only problem now is that I have to come and add this arrow. This arrow is a way of saying a method. So this is saying this starts with last name delegate. It takes a person, you can call it function pointer or something. It takes a person, a letter, and returns this person.last name, and person.last name starts with letter. Let me repeat the same as well for starts with first name. So copy this, put it here. I can now get rid of this, and let's come here and change this to starts with first name. So instead of last name here, this will be first name. In fact, I could just come here and move this on top just to let's call this delegates. Okay, and now I didn't have to declare temporary functions that just hold these particular behaviors. And it turns out that this is a very common pattern, so they now give you yet another way of reducing it. So you can just come here, remove the return because it's implied, remove this semicolon here, and just align it like this. Okay, again, I would have to repeat for this as well. Remove this, put this here, remove this, put this here, and we're done. Now we have two delegates that we are passing in, and again we can reduce this further and get rid of this variable. Okay, get rid of this starts with first name, and just okay, I even forgot, because the type is specified here, you don't even need to declare it as person anymore. You can just say person letter, and that works too, because it will infer the type from the delegate name. Okay, right? And there's still yet one last reduction I can do. So this start with first name. I can cut this entire expression here, bring it here, cut this entire expression here, and bring that here too. Okay, then now I don't even need the delegates anymore, and now we have a filter print that takes people and now takes a predicate that decides how to filter people out. So it takes a person, a letter, and then it says the person get the first name as long as it starts with whatever letter. Okay, so this is the strategy, or this is the delegate, that this is the decision of how filter print should filter the people it's dealing with. And again, I can do Ctrl F5 and run it, and as you can see, it works as expected. So let me change this to first name as well. So let's Ctrl F5 one last time. Sorry, it's supposed to be the other way around. Let's change this to last name. Okay, so I do Ctrl F5. As you can see, this is where we were before. Okay, now yet another thing I want to also do as well is, by convention, people use a single letter to refer to this thing, just to keep the delegate short and simple. Let's call the letter L, and let's change this as well, call it P, and call the letter L as well. Okay, so this is it's starting to look really concise and simple right now. What next? I think what next is for me to I think this is all there is. So by coming here and declaring that this filter print takes a person that takes a person and a string and returns a boolean, I can just come here and say P and L, and it knows what P and L are, and it's able to just get the last name and use that to decide how to print people. So if all of a sudden someone wants to use a different strategy, like if the person dot get full name dot count or dot length or whatever, right? If the length of let's see, LENGTH is greater than, say, 10 characters, if the person's full name is greater than 10 characters as well, then oh sorry, that means I didn't even need the letter. Okay, I could have, sorry, before I even do this, let's simplify it a little further. So I can remove letter from here, simplify my delegate just a little bit. Okay, and okay, no, I need letter. But if I wanted to say, okay, if the full name starts with, I don't know, O, which is kind of the same thing with I'm sorry, L, which is a letter, which is kind of the same thing with first checking if first name, because full name returns the first name as well. Full name starts with first name. So if I do Ctrl F5, as you can see, it also added the extra what do they call it, the extra option. So that's it about delegates. I'll see you next time. Bye.